Hey everyone, so this video is going to cover the three types of solutions that we might get when solving a simultaneous equation, which are a unique solution, no solution, or infinite solutions. And let's look at each case and how these solutions look on a graph. The first case, we have these two simultaneous equations, and there's a couple of ways we can solve this, but let's just use substitution. So since both of these equations are equal to y, we can make the right-hand side equal to each other. So 2x minus 2 is equal to x plus 3. And just by moving some terms around, so x is on one side and constants to the other, we end up with x is equal to 5. And then to get our y value, we just substitute our x value into one of the equations. The second one is probably easier, so if we just go 5 plus 3, we get the y value being 8. So these are our solutions, and let's see how these two equations look on a graph. So y is equal to x plus 3, which looks something like this, with a positive y-intercept of 3, and 2x minus 2, which looks something like this, with a y-intercept of negative 2. Now, I won't label all the points because what I'm trying to show here is that for a unique solution, there's only one point of intersection, which in this case is the point 5, 8. Alright, let's have a look at our second case. If we have these two equations now, we can also solve it using the same method, but let's just use elimination this time. I'm going to label these as equation 1 and equation 2, and I'm going to minus equation 2 from equation 1. So I'm doing y minus y, which is 0, then x minus x, which is 0, and then 1 minus 2, which is negative 1. Now, if you look at this, we end up with 0 is equal to negative 1, which can't be right. So let's have a look at our graph. We draw the graph y is equal to x plus 1, which just has a y-intercept of 1, and it goes from bottom left to top right, like this. And y is equal to x plus 2, which is pretty much the same graph, but slightly higher. The only difference here is the y-intercept. The gradients are the same, which means that these two graphs are parallel lines. And that's why there's no intersection, and therefore there's no solution. Now let's look at the third case, because there's a small exception. So we're given these two equations, and if we look at the second equation, if we simplify this down by dividing everything by 3, we end up with the same equation as equation number 1. So when plotting this, we're essentially just plotting the same graph twice, because they overlap each other at every single point, since they're the same graph. And what this means in terms of solutions, or intersections, is that every single point will be an intersection or a solution. And since these graphs go off to infinity, we have an infinite number of intersections, and therefore we have an infinite number of solutions. And this is the case when we have two equations that are identical, or in other words, they have the same gradient as well as the same y-intercept. So let's summarize what we have here. As we mentioned before, infinite solutions occur when you have two linear equations that have the same gradient and y-intercept, which essentially makes those two equations the same. And then for no solutions, the gradient is the same because that makes these two lines parallel. However, the y-intercept cannot be the same, because if the y-intercept is the same, then that will make these two parallel lines the same equation. This would mean there would be infinite solutions. And then for unique solutions, as long as the gradients are not the same, so that prevents these two lines from being parallel, then these two lines will always have an intersection and therefore a unique solution.